Here it says a company sells radios with a mean life of 18 months and a standard deviation of 3 months. The distribution is approximately normal. If they sell 5,000 radios, how many can they expect will have a life expectancy between 12 months and 24 months? So if the distribution is normal, it's going to look like this graph. We're going to talk about this graph and what it means, but first, let's come up with some of the key data points that we need to label the graph. So first is the mean, which they give us. They're telling us that the mean is 18 months. They're also telling us that the standard deviation is 3 months. That's what we're referring to as S in these calculations. So we're going to take the mean and add 1S and subtract 1S, 1 standard deviation. Now let's take the mean and add 2 standard deviations and subtract 2 standard deviations. And lastly, we're going to take the mean and add 3 standard deviations and subtract 3 standard deviations. Now let's take these key data points and label our normal distribution graph. The mean represents the middle of this curve and the highest point. Now each of these little sections represents 1 standard deviation. So this is 3 months, this is 3 months, this is 3 months. 3 months, 3 months, 3 months. So we are moving 1 standard deviation at a time away from the mean. So if we look at the numbers here in green, if we're going to add 1 standard deviation, we're moving to the right. That gives us 21 months right here. And if we're subtracting 1 standard deviation, we're moving to the left. So that gives us the 15 months here. So 1 standard deviation from the mean. So what is that telling us? Notice here it says 68% of the data is between these 2 lines. So 68% of the data is between 15 months and 21 months. So in this circumstance, 68% of the radios will have a life expectancy between 15 and 21 months. That's what it's telling us. Now let's look at the distance that's 2 standard deviations from the mean. So 12 months and 24 months. So this is telling us that 95% of the data is between 12 and 24 months. 95% of the radios are going to have a life expectancy between 12 and 24 months. And then with 3 standard deviations from the mean, this is telling us that 99.7% of the data, almost all of it, is between 9 and 27 months. So 99.7% of the radios are going to have a life expectancy between 9 and 27 months. So now that we have a better understanding of this graph and have labeled all the key points, let's look at the question. It says if they sell 5,000 radios, how many can they expect to have a life expectancy between 12 and 24 months? So 12 and 24 months are these lines right here, the orange ones. 95% of the radios will last between 12 and 24 months. So what we do is you take 95% and you multiply it by the total number of radios sold. So what is 95% of 5,000? It's 4,750 radios. This is the number of radios we can expect will have a life expectancy between 12 and 24 months.